Kirsten Christensen. Some of you may have attended the first workshop that was on Zoom, and so you're familiar with me a little bit. If not, it was recorded. If you were interested in watching it, it was just an introduction to the idea of data, what it is, how to get it, what to do with it, and an introduction to the program of SPSS, which we will be using today. If you're interested in participating in the third workshop, which is the one where you will bring your own data, and I will work with you. We will work sort of one-on-one, helping you figure out what you can do with your data, what kinds of tests you can run, running some preliminary analyses so you can actually get started with any data that you might have collected that you're using for a project. You can start that process of actually starting to look at your data and analyze it. So that's the third workshop. If you're interested in participating with that, stick around until the end because they were the lovely individuals from the Office of Student Research and Creativity have QR codes that you can scan to get to the form to sign up for that workshop. All right. So hopefully you all have the data set. If you came in a little bit late, it was forwarded to your email. So if you haven't checked your email, the data set that we're going to be using is in there. So I'm going to be demonstrating a few of the more common statistical tests that we use at SPSS. And when I say some of the more common, I mean these are the tests that are the most likely tests that you're going to see people use when they're analyzing their data. Now, there's a lot of different kinds of statistical tests. There's some very, very complicated, sophisticated statistical tests. We're only going to be scratching the surface, but it should give you an idea of kind of some of the really straightforward things that you can do to start analyzing any data that you might have that you are working on a project with. All right. So the data set that we're using it's the GSS. GSS is the General Social Survey. It's a nationwide survey that is conducted semi-regularly. It's not necessarily every exact number of years. Sometimes there's a couple years in between. But this one is from 2018. The General Social Survey asks individuals across the country a variety of different questions about a variety of different topics. The data set that we're using is just a sample from the 2018 GSS. It's not the full survey, it's not the full data set, but this is a little bit more manageable. All right, so if you have the data set from your email, you should go ahead and download it to the computer or to your flash drive if you brought one with you. There's two ways to open up data in SPSS. Most of the time, if you're working with a computer that has SPSS loaded on it, what we call a native app. It is on the actual computer you're working on. You can just double click on an SPSS dataset file and it would open up the program and the file sort of simultaneously. Alternatively, you can also open the program and then open the file through the program. Since that one's a little bit, it requires a few more steps, it's actually the one I'm going to use to show you to open up the data set myself. So I'm going to open up SPSS. We'll give it a second. It can sometimes take a little bit to open up. If you attended the first workshop, I mentioned that SPSS is a program that you don't so much just buy a program, you buy a license to use the program. And so SPSS actually takes a moment when it opens up to go online and verify that the license you have is still valid. So it can take a few minutes sometimes to open up. All right, so this is how SPSS looks if you just open the program. You're not trying to, you didn't double click on a file itself, but this is the program. So I've never used this computer before, so this is a brand new, clean sheet. And so I'm going to click on this tab on the bottom that says Recent Files, and you'll notice that it changes what's in the box to open another file, and it's highlighted. Leave that highlighted and click Open. And then I'm going to navigate to where I put the data set, which in my case was on the desktop. All right. only two of which we're really going to be working with in any, to an extent today. This is the primary window of SPSS. It's called the data editor. The data editor is where you put all your data. So it's where you enter all that information that you collected when you were collecting information from your participants, whether that was a survey or interviews or whatever it was. This is where all the data goes. The data editor has two views, which you can access down here on the bottom left. This is the data view. This is usually what comes up first by default. And everything you see here is information that was collected from the participants. So this is the general social survey. It's United States residents. So every one of these lines, every row, represents an individual person, right? One of the people who filled out the survey or answered the questions. Each of the columns represents a different piece of information that was collected about all those individual people. So each of the columns is a variable. Each of the rows is a case. And all of these numbers inside are the information that we collected on all of the variables from all of the cases. The variable view provides you with a greater amount of information about what specifically was collected, what information was collected from all of these participants. So the very far left of the data editor is a variable name. It's usually something that's very short, usually very abbreviated. It's sometimes completely incomprehensible if you have no idea what questions were asked. It's easier to work with short variable names in SPSS. And so by convention, we do have these names for the variables. They're very short, very abbreviated. But then we also have in the middle here a label column that gives a longer explanation of what each variable is about, what it's measuring. There's a few other columns here that are very important. Next to the label column, you'll see a column called values. Qualitative information, this is information that when you collect it, well, it's sometimes easier to talk about qualitative information as what it's not, which is it's not quantitative information. Quantitative information measures an exact amount of something that each participant has. So if I ask things like, how old are you in years? How many brothers and sisters do you have? How many hours a day do you watch TV? Right? Those are all quantitative questions. I'm going to get a response that's a number. It's going to measure an amount. The number of years since you were born, the number of siblings you have, the number of hours you watch TV. Qualitative information then is all the other information, stuff that isn't measuring an exact quantity of something. So we can separate that into two types, nominal and ordinal. Nominal is just different categories. So things like your favorite color, your race, your religion, what borough you live in, that's all nominal information. There's no quantitative difference. There's not more borough in the Bronx than there is in Queens. Not from a obvious surface point of view. Queens and the Bronx are just different boroughs. So those are nominal. And then ordinal variables have a quantitative order, but it's relative. So things like small, medium, and large. So if you go to a restaurant, for example, and you're ordering a drink, and all it says on the menu is small, medium, and large, you know that if you get a medium, you're getting more soda than if you got a small, but you don't necessarily know how much soda you're getting in either one of those. Those types of variables, that type of information has to be coded. So SPSS is basically just a giant calculator. And so really it only understands numbers, it only speaks in numbers. So anytime you have a variable that is qualitative, you have to assign number codes to the word responses. So for example, we have a variable like, does the respondent own or rent their home? So the possible answers to this are the respondent, the participant, owns or is buying their own home. They pay rent, or there's an other category for a variety of other types of living arrangements that you might have. But none of these is quantitative, right? This is just you own your home, or you're buying your home, or you rent, or you have some other arrangement. This is a nominal level variable. And so instead of using the actual responses we got, which is I own my own home, I pay rent, I'm buying my own home, whatever it is, we assign a number code to those responses. It's called coding. We code qualitative information. The values column is where you can find information about the codes for the qualitative variables. The next important column is the missing column. Regardless of how you're collecting your information, whether you're surveying people face-to-face, whether you're getting information out of criminal court case files, it's inevitable, especially when you gather a lot of information from a lot of people, that there will be some questions or some pieces of information that you don't record or you can't get for every single participant in your sample. So we always want to create a code, assign a number value to something, but this time it's for a specific kind of something, which is missing data. Missing data just means you don't have an answer for that person. So let's say that you survey people and you survey 100 people and 99 of them answer the last question and one person just left it blank. You're not going to remove that person from your data set because they answered all the other questions. But in that particular question, in that variable column, you don't want to leave the space blank. SPSS does not like blank spaces. In fact, it dislikes them so much that it refuses to allow a blank space, which you'll see is a cell with a dot in the middle of it. But that's what SPSS calls system missing, and system missing cells mess with SPSS's programming. Some things you can do with those system missing cells in SPSS is fine, and then other times you'll try to do something, and suddenly you get these really bizarre results because there's too many what it considers blank cells. So we assign a code to missing. We come up with a number that we are going to say this represents missing data, and we enter those numbers into the cells. So the cells aren't blank anymore. They don't just have that dot in there. There is a number in there, but that number tells SPSS that this is missing data. You can ignore this cell when you're running your analyses, yeah.
Doesn't matter what number it is.
As long as it can't be a valid response. So for example, if you're asking people how old they are in years, you wouldn't want to use a number like 99 as your missing code because while it's not as common, it is possible to be 99 years old. So it is possible that you can have people in your data set who are legitimately 99 years old, and if you made that your missing code, SPSS would think you don't know how old they are. So it can be any number you want as long as it's not a number that could be a valid response. Okay, and then the last column that we want to pay some attention to is this column here that says measure. Measure has to do with the scale of measurement. Goes back to what I was saying about quantitative and qualitative information. Because the statistics that we do with qualitative and quantitative information differs, right? You can't do the same things with quantitative or with qualitative data that you can do with quantitative data. It does matter, actually, in the program what scale of measurement the variable is on. SPSS recognizes 3 different measure categories. Nominal and ordinal, which I talked about a few minutes ago. Nominal being just different categories. People just fall into different categories. It's your favorite color. It's your favorite toppings on pizza, right? Things like that. Ordinal are the ones that can be rank ordered, but you still don't have an exact quantity. So Olympic medal colors, bronze, silver, gold, right? You can tell who did better and who didn't do as well, but you don't know how well anyone actually did exactly. And then the quantitative variables are all lumped together under one type, which SPSS calls scale. Scale is just your quantitative information. So anything that measures an exact quantity for each person in the data set. So how old are you in years? How many brothers and sisters do you have? Those all get lumped together under scale. So knowing what level of measurement your variable's on and having it correctly formatted in the data set are important because SPSS will push back. If you try to run an analysis that's supposed to be run on quantitative variables and you try to run it on variables that have been programmed to be qualitative variables, SPSS will push back and say you can't do that. So you want to make sure that you have correct or appropriate information in this column for the variables that you're working with. Okay. Now, generally speaking, if you're working with a data set like this one that has a lot of variables, usually the first thing you want to do is clean your data, and that doesn't mean you have to clean the whole data set necessarily. Even though this is just a smaller sample of the general social survey, still has a lot of data in it. There's still, let's see, what is it, 100 and something variables, I think? Oh, no, not that many, 45 variables. And there's something like, there's at least a few thousand participants that are represented here. So we're not necessarily going to open a data set and clean every single variable, every single bit of the data set. But you want to make sure that you are aware of the columns that I just mentioned. You're aware of the values column, the missing column, and the measure column for the variables you're actually going to use. Okay, so the tests that I'm going to go through right now are, like I said, they're among the more common tests that you'll see. They're also some of the more straightforward. This is where when you're first starting to look at your data, you're first starting to analyze your data, these are some of the first things that you're going to look at. One of the first things you should always do is run frequency distribution tables on the variables you're about to use. In part, this goes along with the cleaning process, making sure your data is ready to be analyzed. But it also gives you a lot of information about your variables, because as I mentioned before, you can't run the same types of analyses with qualitative variables that you do with quantitative variables. So when you're starting to work with a data set, you need to run frequency distribution tables on the variables you're going to work with so that you can get a couple of pieces of information. One, you can make sure that the variable looks okay. It doesn't look like there are any typos or data entry errors. Everything's labeled appropriately if it's a qualitative variable. And it also will give you a chance to see what kind of variable it is. Because another part of the thing that you have to be aware of with SPSS is if whoever entered the data into SPSS did not go through and set all of these up to be the correct level of measurement for each variable, SPSS will guess, and it doesn't always guess right. So you want to look at the variable in a frequency distribution table as opposed to just relying on what SPSS is telling you that it is. So SPSS, for example, is telling me that all these variables right here are nominal variables. That's not necessarily true. So running a frequency distribution table is the best way to get a look at your variable, make sure that it looks okay, figure out what kind of variable it is, and that tells you a lot about what kinds of tests you can run. Okay, so the four tests that we're going to look at. Very good marker. So we're going to take a look at the independent samples t-test, the chi-square test of independence, and then correlation and regression, which are technically two different analyses, but they really are very, very highly related to each other. So they regression kind of builds off of what correlation starts you doing. All right, the independent samples t-test is a test that we use to compare two separate groups of participants on some quantitative variable. Specifically, what we're doing is we're taking our two separate groups of participants, we're calculating the mean on that quantitative variable for the first group and the mean on that same quantitative variable for the second group, and seeing if the means are different. Now, if you're working with a sample, if you're working with sample data, which you almost always are, the means of the two groups can be a little bit different, and what we're assessing is whether whatever small difference we might see, or whatever difference we do see between the means of the two groups, whether the difference is too big to be just sampling error. Sampling error means that when you take samples from a population, the samples aren't always going to be exactly like each other. They're not going to be exactly like the population they came from, and they're not going to be exactly like each other, because there's a little bit of variability in the way people score on your quantitative variable. And some people are going to score kind of high, and some people are going to score kind of low, and it's possible to get a sample of people by accident who all score high or who all score low. And so a little bit of difference between the means of the two groups is not unusual. It's not unexpected. What the independent samples t-test does is it looks at the difference between the two sample means and tries to determine if that difference is big enough to rule out sampling error, to say there really is a difference, a real difference between these two groups of people. The chi-square test of independence is used to test for associations or relationships between variables when you have two qualitative variables. Correlation is used to look for associations or relationships between variables when you have quantitative variables. And regression builds off of correlation to take it one step further, to not just look for an association, but actually to start building predictive models from quantitative, primarily quantitative information. That's what we're mostly going to focus on. Yeah.
Because independent is qualitative plus quantitative. And
Yeah,
then
yeah.
correlation is
So-
quantitative plus quantitative.
Right.
Okay.
So when you're thinking about the variables, especially, like I said, the scale of measurement, the level of measurement, whether it's nominal, ordinal, or scale, matters. When you're looking at your variables, independent samples t-tests have two variables. One is a qualitative variable. What SPSS is, you'll see this, SPSS calls it a grouping variable, which creates your two groups. And then the other is your quantitative variable, which you're comparing the means for the two groups on that variable. The chi-square test of independence, you have two qualitative variables. Correlation, you have two quantitative variables. And the type of regression we're going to look at, you also would have two quantitative variables. So if you're looking at your variables and you see that you want to see if there's a relationship between how people answer one question and how they tend to answer another question, and you look at the two question variables and you notice that they're both qualitative, then you know you're going to want to run a chi-square test of independence. If you look at them and you see that they're both quantitative, then you know you're going to be running a correlation instead. Okay? All right, so looking back at the variable view, the kinds of variables that are in this data set, you can see some of the questions. Again, this is just a sample. This is not the full list of all the questions that are asked. The GSS is a very, very long survey. So you can see things like, there's some demographic information in here. You'll notice there's things like the respondent's age, whether they own or rent their home. We saw that one already. Number of hours worked last week. Then there's also some questions that are about social issues, right? So there's questions about whether the person believes that abortion should be legal if a woman wants it for any reason. They asked them whether they think abortion should be legal if the woman is pregnant as a result of rape. Asked things about whether they favor or oppose the death penalty. Right, so there's a variety of different kinds of questions in here. Some of this information is going to be qualitative, some of it's going to be quantitative. All right, so looking at the independent samples t-test, again, we take our full data set and we have a qualitative variable which separates the data set into two different groups of people. And then we have a quantitative variable, which is what we're comparing the means from. Okay, so for example, if I wanted to know whether there was a relationship between, whether or not a respondent uses a computer and the total dollar value of their pay in the previous year. All right, again, remember the first thing you want to do is run frequency distribution tables. All right, so I want to know whether or not your income makes a difference to whether or not you use a computer. Perhaps my theory is that people who made more money in the previous year will be more likely to use a computer, and so I want to test that to see if that's true. In this data set, are the people here who use a computer will they also have a higher average income in the previous year than the people who don't use a computer? All right, so the first thing I'm going to do is I'm going to run frequency distribution tables. So I do that by going to Analyze, the Analyze menu, Descriptive Statistics, and Frequencies. and this is the dialog box. All right, the dialog box will usually come up first with the variable labels. So this longer description of what the variable is what you'll see. So the variable labels are usually fairly long. They're a lot harder to work with. It's a lot harder to find the variable you're interested in if you use the variable label. So you can right-click on the variable list and resort it by variable name, which gives us those shorter names. And you can also sort it by alphabetical order if you have a data set that has a long list of variables. You can also right-click on it again and sort it by alphabetical order, which it just makes it easier to find the variables you're looking for. All right, so the two variables I'm using here two variables we're going to use are compUse and extraval. That's their short variable name. So compUse was just the question of respondent uses a computer, right? Yes or no. And then extraval is total dollar value of pay in previous year. And this is a quantitative variable, but we'll see that when we run the frequency distribution tables. All right, this particular data set, the variables actually are already sorted in mostly alphabetical order. So you don't need to do that second step usually in this data set. But I'm going to find my two variables, compUse. Click on it, click the right arrow to move it over into the variables box. Find my second variable and move it over into the variables box. And click OK. All right, so here's my two variables. Frequency distribution table just gives me the different levels of the variable and the number of participants in each level. We're only concerned about the sections of these tables that say valid. As long as the missing has something listed in there. So for example, you see missing, it says IAP. So that's fine. We're not worried about those cases. And our other variable here, again, we're looking to see if it looks okay. Again, mostly what we're looking for is to make sure that nothing seems out of order. Does respondent use a computer? Yes or no? That makes sense. Those are the two valid options. They either do or they don't. This also tells us that that is a nominal variable because it's just yes or no. They either do or they don't. Our second variable, which is total dollar value of pay in previous year, if we look on the left-hand side, this is all of the different responses that we got from all the participants. And as long as every single one of those responses, every value on each row is a single specific number in our valid section, which it is, then that tells us that this is a quantitative variable. All right? So we have a qualitative variable that has two levels, yes and no, and we have a quantitative variable, and that makes these two variables eligible for an independent samples t-test. Because our compUse variable is going to separate our data set into two groups, and SPSS is going to calculate the mean for extraval for the first group, the one that uses the computers, and the mean for extraval for the second group, the group that doesn't use computers, and compare those two means to each other. Okay. To run the independent samples t-test, we'll go back to that Analyze menu. And now we're going to go down to where it says Compare Means and Proportions. And you'll see that our third option here is the independent samples t-test. All right, every time you open a new dialog box, it defaults back to showing the variables by variable labels. So again, you can just right-click anywhere on that list of variables and change to variable names. All right, so the independent samples t-test separates the data set into two groups using a grouping variable. This one's going to be our qualitative variable, which in this case is compUse. But when I move compUse over into the grouping variable box, you'll notice that what you see here are 2 question marks. SPSS requires you to tell it the number codes for the groups. So remember, we code all qualitative information. Using a computer or not, yes or no, is just a nominal information. And so instead of using the words yes and no, we code yes with a number, we assign a number to yes and assign a number to no. So one of the things we need is those number codes. So I'm going to go back to the data editor, back to variable view. I'm going to find my comp use variable and I'm going to open up the values box. And I can see that the number assigned to yes was 1 and the number assigned to no was 2. Those are the number codes I'm going to enter into the independent samples dialog box. All right, so I'm going to click on the button that says define groups. SPSS actually already has a default fill-in for these, which is always going to be 1 and 2. Sometimes that's going to be fine because in our case that's exactly what we want, right? We want group 1 was yes, so we want the 1, and no was 2, so we want the 2. You should always be careful though. Don't assume that your variable is going to be coded 1 or 2, because actually it's more common usually with data to code yes and no questions as 0 and 1, not 1 and 2. Partly because it's intuitive, the idea of no being 0 makes sense to us, right? No, none, 0. So don't always assume. Always go back to the variable and check to see what the number codes are for the groups you want to compare. And make sure that you have the correct ones in the define groups box. In this case, as I said, the default that SPSS has actually works for us, so we'll click continue. And now I'm going to find my other variable, which is my quantitative variable, and move that over into the test variables box.
So just disregard the other values?
Yeah, those,
Okay.
yeah. We can only compare 2 groups at a time in this test, so we can only compare the yes group to the no group.
Okay.
Those other 3 codes are missing codes anyway, but even so, even if they were other valid groups, we could only, we have to pick,
It is.
we can only pick 2 anyway for this kind of a test.
Yeah, 'cause don't know now.
Okay, so once I have my variables in there and I've defined the group codes that I'm looking at, I can click OK. Okay. The independent samples t-test, well actually let me rephrase this. All hypothesis tests, all statistical tests have certain assumptions, right? Certain things that have to be true for the calculations that the test is making to be accurate. A lot of the assumptions are very, very common to a lot of tests, things like the assumption of normality. We assume we're working with a normal distribution, for example. Anytime you compare separate groups of people to each other, there's a specific assumption, and this is an assumption that has to be tested. And this is it's called the assumption of homogeneity of variance, also sometimes renamed the equality of variances assumption, because it essentially means the same thing. There are 2 versions of the independent samples t-test. One is run when the variances of the 2 groups are equal, and one is run when the variances between the 2 groups is not equal. So the first thing we have to do is we actually have to test whether the variances are equal or not. Okay, so general rule of thumb in social science research is any p-value that's less than 0.05 is considered statistically significant. If we're comparing 2 groups of people, that means we're concluding that they're statistically significantly different from each other on our, in this case, our quantitative variable here, the extra val variable. But in this case, we're looking at the variances, not the means. So, SPSS is programmed to call the p-value either sig or p. Newer versions now actually are starting to pull the p letter in instead, but you'll still see sig pop up from time to time. But this is our number that represents our criteria, right? If in this first section of the table, if our sig value here was less than 0.05, we would say that the 2 groups are statistically significantly different in their variances. If it's not, as it isn't here, we would conclude that the 2 groups are not statistically significantly different in their variances. In this case, because we are saying they are not variances are not different, we can use the top t-test, which is the one we run when the variances are equal. If this sig value had been less than 0.05, then we would conclude that the variances are not equal, and we'd use the bottom t-test. So SPSS actually generates everything you need here, right? It generates more than you need, really, because you look at this test here, then you figure out which t-test line you want, and then that t-test line is the one you're actually using to determine if there's a relationship between these variables. Okay, so I wanted to know if there's a difference in the average salary last year or in the previous year for people who use computers and people who don't. I can assume the variances are equal according to this test, so I can use the top t-test line. And I can see that my p-values here are both greater than 0.05. A one-sided p, two-sided p just refers to whether or not you're running a directional or non-directional test. So if I'm just looking to see if there's a difference, this is a two-sided test. If I'm looking to see whether people who use computers have a higher mean salary in the previous year, that's a one-sided test because I'm predicting which group will have the higher mean. So if I'm running this just to see if there's any difference at all, I can look at my two-sided p, and I can see that my p-value is greater than 0.05. Again, if it was less than 0.05, we would conclude the two groups are statistically significantly different. Since it's not, we're going to conclude that there's no statistically significant difference between the means of the two groups. Now, it can get a little confusing because if you look at the means in the table above it, those means look very, very different. The mean salary in the previous year for the yes group is a lot higher than the mean salary for the no group. But the reason why is because the no group only has 10 people in it. 10 people is a very small sample. The smaller your sample, the more sampling error you have, and the less likely it is that any difference in the means is going to be statistically significant, a real difference. It's too possible that we just happen to get 10 people who don't use computers who also have very low salaries, but that doesn't mean that people who don't use computers will tend to have low salaries. Okay, so that's how you run the test, and then the key pieces of information. The first test here tells you which of the t-tests to run. The t-tests are actually about comparing the means of the two groups to see if people who use computers had a higher salary in the previous year than people who don't.
Would you lose points? I mean, this is for our Saturday class. Would you lose points if on the qualifying exam if you say that, like, there could be an error because the sample is too small?
Ask me.
Oh, on Saturday?
Yeah, or send me an email.
Okay, I'll send you an
Okay.
email. I'll write it right now.
Okay, so does this make sense? Yeah? Okay. All right, I'm going to run a second one just to show you, just again, a little extra practice, because this one has a little bit more moving parts than the other ones that we're looking at today. All right, so the next thing I wanted to know when looking at the data that was collected from the General Social Survey was whether or not there was a relationship, let me go back to the variable view, between the age of respondents, how old a person is, and whether or not what their feeling is or what their opinion is about abortion being legal if a woman wants it for any reason. So again, I'm going to run frequencies for this. Right? SPSS always remembers the last thing you did, so I'll need to get rid of those. And my two variables now are age, which is the age of the respondent, and ab ini, which is abortion if a woman wants for any reason. Alright, so let me find my variables. Alright, so I want to analyze descriptive statistics in frequencies again. I find my two variables, age and ab ini, and I click OK to run frequency tables. Alright, the first variable that comes up is age, and again, I'm just looking to see if all of the values for the age variable in the valid section, if they're all exact numbers, right, a single exact number. They are. That makes this a quantitative variable. And then I'm looking to see how my other variable, ab ini, what the answers here are. And again, this is a yes or no question. So people either said yes, abortion should be legal if a woman wants it for any reason, or they said no, it should not be. Again, before I run this, I need to know how my qualitative variable is coded. So I go back to variable view, and I look to see what the codes are for yes and no for my ab/any variable. And it is again 1 and 2. Okay. Then I'll go to analyze, compare means and proportions, and independent samples t-test. Again, it's going to remove the variables from the previous example. All right, so which one am I putting in the grouping variable box? Which one? Yeah, ab/any, right? Because that was my yes or no variable. That's my qualitative variable. So I'm going to move that into grouping. And again, SPSS wants the codes. And again, luckily, in this case, the codes are 1 and 2 for the two groups, yes and no. Just want to make sure that it says 1 and 2 there. And then I'll take my age variable and move it into the test variables box. And click OK. All right, so where's the first place I need to look? Yeah, SIG. Specifically, I want to look at these first two set of numbers, right? Well, the second of the two numbers, really. And I want to see whether or not I can conclude that the variances are equal or not. So the SIG value here is 0.146, which is greater than 0.05. So we're going to conclude that. Are we going to conclude the variances are equal, or are we going to say that they're not equal? So remember, this is greater than 0.05, so that means that the variances are equal or unequal. All right, so if the SIG value in this test is less than 0.05, then we would conclude that they're statistically significantly different. If it's greater than 0.05, then we would not conclude they're statistically significantly different, which in common language is we're going to conclude they're the same, that the variances are equal. All right, so again, we're going to use this. We're going to use the top t-test line. And let's say again that this is a two-sided test, that I just wanted to see if there's a difference in the average age of people who believe abortion should be legal for any reason, and those people who do not believe it should be legal for any reason. So I'm going to go to my two-sided P, and what it says is less than 0.001. All right, which means it's a very, very small number. SPSS will not display a p-value that is a long string of decimals with 15 zeros after the decimal places, so it abbreviates it essentially. So whatever the p-value actually is, we do know that it's less than 0.05, because if it's less than 0.001, then it's also less than 0.05. And again, if P or SIG, however it's labeled, is less than 0.05, then we conclude that the groups are statistically significantly different. In this case, we would conclude that the average age for people who believe abortion should be legal for any reason and people who don't believe that is statistically significantly different. In which case, we can go to that top table there that says group statistics, and we can look at the average ages of the two groups. So we can see that the average age for people who said yes, it should be legal for any reason, is 45.86. The average age of people who said no to this question was 49.39. So we can say that people who said no, that they do not believe abortion should be legal if a woman wants it for any reason, are statistically significantly older on average than the people who believe it should be legal. Okay. So the independent samples t-test is about comparing two different groups of people. You'll have two variables, one of which is a qualitative variable, which you can use to separate the data set into your two separate groups of people. And then the other is your quantitative variable, which are the means of the two groups that you're comparing. Okay, questions on this one? Yeah.
If they're not significant, do you just put not significant?
Not significant,
okay.
yeah. Not statistically.
Don't report the don't report the F in that case.
It's not the F that we're really that concerned about.
Okay.
Really, we're comparing the means.
I'm
we're-
thinking of
we're
the
comparing,
V.
Yeah, the T.
Thank you.
Was there another question? In the back, maybe? No?
That's right, T-test.
Okay. The chi-square test of independence and the correlations test are both about testing associations or relationships. Essentially, they're both about testing for patterns. Patterns are really, really useful to us in science because patterns allow us to make predictions. So if I know that people who answer one question a certain way will also tend to answer some other question a particular way, then I can look to see what a person's answer is to the first question and predict what they're going to answer to the second question. We use it for a variety of different things, right? We use it to predict, criminal justice systems will use it to predict risk, right? The risk of future dangerousness or the risk of someone reoffending after release. Parole boards will use this, right, to determine whether or not to grant parole. Because there are certain behavioral metrics, let's call them, that have been shown to be associated with particular kinds of behavior. So we can use those metrics to try to predict what's going to happen for someone in the future. We could look at this in colleges and universities as well. Colleges and universities have used things like this to try to predict who's going to successfully graduate from college, because there are different things that have been found to be associated with a higher likelihood of successfully graduating or not. So they're incredibly useful to us to determine whether there's a pattern in the data, whether there's a pattern between two variables. Means that we can then, and that pattern is real and not just, again, not just sampling error, not just sort of a random chance pattern that occurred because of who we selected to be in our study. If we can establish that there's a real pattern, then we can use those patterns to try to predict what's going to happen. Law enforcement uses this, for example, to try to figure out where to put police officers. Sometimes you'll have more police officers in certain areas of the city at certain times of day or night. And that's because the police department has predicted that they will need more police officers in that area at that time of day or that time of night. All right, so the chi-square test of independence is used when we want to establish whether there's a pattern or an association between two qualitative variables. And correlation is used when we want to establish whether there's a relationship or pattern between two quantitative variables. All right. So for example, again, going back to my variable view, let's say that I wanted to know whether there was a relationship between how people felt about what is being done to halt the rising crime rate and whether or not they believe or whether or not they favor or oppose gun permits. Okay? So I want to know if there's a relationship between these things, right? Perhaps I think that people who don't think enough is being done to halt the rising crime rate would be more in favor of gun permits or maybe less in favor of gun permits. But I think there's going to be a pattern. I think it's going to matter whether that people who favor gun permits are going to be more likely to answer questions about the rising crime rate a certain way compared to people who don't favor gun permits. All right, both of these variables, if I run frequency tables, both of these variables, and let me write the variable names down here. Right, nat crime and gun law. Both of these variables, if I run the frequency tables on them, both of these are qualitative variables. All right, the options for favoring or opposing gun permits is just favoring or opposing. And the options for what is being done to halt the rising crime rate are too little, about right, or too much. Okay, so the first variable is nominal. It's just you favor it or you oppose it. The second variable is ordinal, because you can see that there's an increase in whether they think enough is being done, right, from too little, about right, to too much. Since these are both qualitative variables, the test to see if there's a pattern, to see if there's an association between these variables, whether how you feel about gun permits is related to how you feel about the rising crime rate or what's being done about it. Both of these are, as qualitative variables means that this is a chi-square test of independence situation. To run the chi-square test of independence, you'll go to Analyze, Descriptive Statistics, and Crosstabs. Right, again, I'm going to display variable names here. Okay, so in this dialog box, you can see on the right side here, there are these two boxes. One says rows and one says columns. You're going to put one of the two variables in rows and the other one in columns. The general rule of thumb or rules of thumb for which you put where, there's two of them. One is if you are testing a theory that one thing is leading to another, that it's how people feel about what's being done about the rising crime rate that influences whether or not they favor or oppose gun laws, then you have what are sort of loosely referred to as independent and dependent variables. The independent variable is the one you think is influencing the other. In that case, you want to put the independent variable in columns and the dependent variable in rows, and the only reason why is because it makes the table easier to interpret. It really doesn't matter in terms of the test itself which one you put where, but in terms of actually interpreting what you get from SPSS, it's easier if your independent variable is in the columns of the table. If there is no clear independent or dependent variable, which isn't that uncommon, sometimes we don't know if it's how people feel about the rising crime rate that influences whether they favor or oppose gun permits. Maybe how they feel about gun permits has an influence on how they feel about the rising crime rate. So if there's no clear independent or dependent variable, then the other rule of thumb is to put the one that has the fewest levels in columns. And again, this is just for practical reasons. It's easier to read a table that's long than it is to read one that's wide. All right, so for this particular one, I'm going to put nat crime in columns.
It has 3 levels.
Yeah, for this one, it's not going to necessarily, for this one, it's not necessarily going to matter because 3 columns isn't that bad.
Okay.
But also because I'm sort of testing a theory that how people feel about the crime rate would be influencing how they feel about permits, gun permits, and not the other way around. All right, so I'm going to put nat crime in columns and gun law in rows. All right, now, in addition to this, in order to actually get the statistical test, we need to click the button that says Statistics in the top right and check the box that says chi-square. All right, then click Continue to get out of that dialog box. And then the other thing we want is to click the Cells button and ask for column percentages. So that's about in the middle on the left-hand side. You'll see where it says percentages. You want to check the box for column percentages. Percentages make it easier to interpret the table. Again, this is about making the output easy to read, easy to interpret. Percentages can highlight the relative differences between the different groups on each of the variable better than the raw value, the raw frequencies. So you want column percentages. You do not want to necessarily check a lot of boxes in this dialog box, by the way, just as a practical sense. If you want more things at some point, you probably should run the chi-square a couple of times, because every single box you check in here creates another number in each cell of the table that you're going to generate. So if each cell of your table has 10 numbers in it, it becomes very, very difficult to read. So you want to make sure that you're just selecting the necessary ones, and if you really want a lot, that you just rerun it a couple of times and just check different boxes so that you get all the information you want, but in a way that's easily readable. All right, I'm going to click Continue, and I'm going to click OK. All right, we get a bunch of tables here. The first one we want to look at, though, is actually the third one, because this is the one that tells us whether there's a statistically significant pattern. Again, a statistically significant pattern tells us that it does depend. How you feel about gun permits does depend on how you feel about what's being done about the rising crime rate, and vice versa. So we come down here, we come to our first line here, which is our chi-square. And again, we go to our significance column. And if this is then we would conclude that there is a statistically significant relationship.
Are you not measuring level of association?
Not in this particular case, no. We're just looking to see if there is one at all. All right, so it's because our p-value in our chi-square is less than 0.05, it's 0.022. That means that there is a statistically significant pattern, there is a statistically significant relationship between the variables. And then we'll go to the second table that we get, which is our chi-square matrix. And what we're looking at is we're looking at those percentage values. And because we did percentages on the columns, we can read them across. So we can look at, for example, the people who said they favor gun permits. And you'll notice that if you look at the percentages, people who said they favor gun permits were more likely to say, or actually let me rephrase this to be a little bit more accurate. People who said that too little was being done to halt the rising crime rate are more likely to favor gun permits than oppose. And if you compare them to people who said what's being done to halt the rising crime rate is about right, you can see that even though more people in that case still favored gun permits, it's a lower percentage in that group. So if you think too little is being done to halt the violent crime rate, you're more likely to favor gun permits than if you think what's being done is about right or too much, right? And the higher, I guess, the level of intervention you think is being done to halt the violent crime rate, rising crime rate, the less likely it is that you'll favor gun permits, right? You can see that the percentage of favoring gun permits goes down as you move from the too little to the about right to the too much group. Okay, so if we were looking at this and determining what the relationship is, we would say that people who think too little is being done are more likely to favor gun permits, and the more you think is being done to halt the violent crime rate, or for those people who think too much is being done, they are less likely to favor. Still more likely to favor than oppose, but less likely to favor than people who think too little is being done. Okay? All right, so again, with the chi-square test of independence, the first thing we want to look at is actually the third table, because we want to see if the pattern's statistically significant in the first place. And if the p-value is less than 0.05, then it is a statistically significant pattern. And then we can use the chi-square matrix itself to interpret what that relationship is. And again, those column percentages make that a little easier. You can compare the percentages across, and that gives you a better idea of which groups on one variable are more likely to be in specific levels of the other variable. Okay. Yeah.
The chi-square count for p-values, maybe the p-value is like more like 0.5. You don't have to look at those chi-square.
Right, exactly, because we would determine that the pattern is not statistically significant. So there doesn't seem to be a relationship between the two variables. It doesn't seem to matter, right, how you feel about the rising crime rate, and that has no influence on whether you approve or oppose of gun permits.
So if you search, you have to say there's no causal relationship.
Yeah, there's no relationship between the two variables. Or there's no statistically significant relationship, to use a more accurate terminology. All right, if we wanted to look for a relationship between two quantitative variables, then we want to use a correlation instead of a chi-square. A correlation is doing a very, very similar thing conceptually to what this chi-square test of independence does. It's again looking to see whether how you score on one variable is related to how you're going to score on another variable. All right, so if I wanted to look to see if there's a relationship between a person's age and how many hours they spend on their email per week. If I run a frequency distribution table of these two variables, right, and these two variables are we've actually already looked at. But just to be comprehensive here, I'll run them both. And again, what I'm looking at is the left side column. I'm looking to see if it's numbers, the left side column, and if each row has its own specific exact number in it. And as I scroll down the age table, I see that yes, that is true. They're all individual exact numbers. And as I scroll down the email hours per week variable, again, I see the same thing. They're all, every row is its own specific individual exact number. So these are both quantitative variables. To run a correlation, again, going to the Analyze drop-down menu, and now if you go about halfway down, you'll see it says Correlate. Correlation and regression, by the way, are a huge area of statistics. There are so many different permutations of, especially regression, but also correlation. So you'll notice that there's a few options here, but what we want is bivariate. Bivariate just means there's two variables. Bi for two, variate for variables. So we're looking at two variables. All right, so I'm going to find my two variables. It does not matter where you put these or in what order, because for SPSS, it's just looking for a pattern. It's not concerned about which one might be an independent and which one might be a dependent variable in the correlations test. It's just looking at the two variables themselves in any order. All right, there's a bunch of default things checked here. Usually you'll just want to leave those checked. Pearson's R test is the most common correlations procedure. Two-tailed means that we're looking for any kind of a relationship. And then flagging significant correlations can be helpful in interpreting the table, the output table. All right, now the output you get for the correlations test is very minimal. It's just one table. Everything you need is contained in this one table. It also is a little bit repetitious because what it does is it places both of the variables along the columns and down the rows. So you actually get this diagonal of cells that has the value 1 in it because that's each variable correlated with itself. So outside the diagonals, to the upper right and the bottom left of the diagonal, is actually a repeat. So this cell up here in the top right is the relationship between age and email hours, and this cell in the bottom left is the same thing. It's also the relationship between age and email hours. So usually when we're interpreting on these tables, you find the diagonal and then you pick a side, because the other side is just a mirror image. It's just repetition. So there's 3 pieces of information in each cell. One is the Pearson's correlation statistic, which is the symbol we use is the letter R. That's the first number. Second number is the sig value. And then the third number is the N. It's the number of participants that are being analyzed. The first thing we want to look at is that sig value, that second number in the cell. We want to see if it's less than 0.05. And again, just like with the chi-square test, if it's less than 0.05, we're going to conclude there's a statistically significant relationship. And the R value then tells us what kind of a relationship. So since this sig value is less than 0.05, we determine there is a statistically significant relationship. We then go up to the number. The number is a negative value. The correlation statistic is negative 0.069. So that tells me there's a negative relationship between the variables. And what that means is that higher values on one are associated with lower values on the other. In this case, that would indicate to us that older respondents spend less time using email per week, and younger respondents spend more time using email per week. Okay? So this tells us that yes, there is a pattern. Yes, it is statistically significant, and it looks like the older you are, the less hours per week you spend using your email. Younger people use email more often than older people, right? A variety of different ways that you can express that interpretation. A positive relationship, by the way, would be indicated by a positive number for the correlation, for the Pearson correlation value. And that just means that the sort of relative values of the numbers are the same. High values on one are associated with high values on the other variable. Low values on one variable are associated with low values on the other. Okay. Regression essentially builds off correlation. Regression is found in SPSS directly underneath where you see correlate. And this shows you, I told you there's a lot of different regression techniques, and this gives you a sort of hint of what I mean by that. The most basic type of regression is a linear regression analysis. So if we go to that second option there, I can enter the same variables that I used in the correlation, age and email hours. In this case, I now sort of want to differentiate between an independent and a dependent. So for example, I might theorize that it's your age that influences how many hours you spend on your email. And so that means that age would be my independent variable, and email hours would be my dependent variable. All right, you get a lot more output with regression than you did for correlation. But a lot of what's on here is actually sort of repeating what we saw in the correlations box. Remember that the correlation statistic was 0.069, and you can actually see that 0.069 repeated. Here you'll actually see it in its negative form. So this is just the correlation between the two variables that we saw in the correlation table. The key thing about this, though, is that regression allows us to create an equation. Which is the linear equation. What that means is that I can plug in the value for age for any individual, and I can calculate a prediction of how many hours they spend using their email per week. So not just predict that the younger they are, the more often they'll use it, but this will actually allow me to create a more specific prediction of how many hours I actually think they are spending on their email, given what their age is. So the regression output gives us the numbers for A and B. And it does it right here on the left-hand side of the coefficients box. The constant is our A, and the number next to age of respondent is our value for B. We can take these numbers, replace A and B in the equation with those numbers, and I create a prediction device. I can plug in someone's age and calculate out a predicted number of email hours. So this goes back to what I said about prediction being something that's used a lot. If you think about my example of law enforcement agencies using prediction to try to figure out where to put their police officers at any given time, this is one of the ways they can do that. Right? They can plug in different factors like the day of the week, the time of day, anything else that might be correlated with crime rates. You can plug in temperature, you can plug in all sorts of things, right? And that will allow you to predict what the level of crime might be in a particular neighborhood. And that will then tell you how you should respond. Do you need more officers there? Do you need less officers there? These kinds of equations can be used to make those more specific estimates of the values of a variable from other factors that are related to it. Okay, questions? Okay, so that was a whirlwind tour of some of the more common tests in SPSS. Okay, if there are no questions, make sure that you check in with our Office of Student Research and Creativity individuals to get the QR code if you're interested in signing up for the third workshop, where we'll be working with your data, not